Hello, everybody, and welcome to Technology Today for May 18th, 2025. It's Season 2, Episode 20. I am Mayor Watt. The sentient AI isn't available today for the show, and it's time machine. Well, it was going to be quick, but it's a time machine episode. Today, we're going to be talking about 5 articles: Quake proofing transformers, virtual time freezing, tiny chip eye brain memory, new DNA structures, and wipeout ear infections. That's right. Everything's powered by ohmtown.com. This is the front page of ohmtown.com. What we're really here is to see technology today, and we are going to see 5 articles on the other side of our intro. All right, let's get right on into it. We're going to talk about hardening the grid. Research team focused on quake-proofing transformer bushings. Keeping the nation's lights on is no small job. The grid we take for granted involves large, expensive equipment, most notably power transformers, and if one goes down, it can take more than a year to replace it and at massive costs. In heavily populated, seismically active areas like California or the Pacific Northwest, time is not a luxury. If it happens anywhere, it's not a luxury. By the way, things are going to get more expensive because these things have been made overseas before, but now they're not coming across because tariffs are so expensive. But not everybody is getting tariffed the same way. So we'll see what happens. But for instance, I was just talking about the fact that laser cutter, laser engraver that I have has now doubled in price from where it was perpetually on sale since its inception. Pretty amazing. So now it's really, really expensive. But anyway, that's not what we're here to talk about. We're here to talk about Paul Menser from the Idaho National Laboratory, who put together this article. It's published over at techexplore.com. During an earthquake, the place where a large high voltage power transformer is most vulnerable is its bushings, hollow electrical insulators that safely guide current between a transformer's internal windings and the external power lines. They're most often made of porcelain due to its ability to isolate the conducting material, usually copper or aluminum, and keep high voltage current from leaking or sparking and causing explosions. Yes, transformers can explode, and it's usually very violent. If you ever get the gumption to go and look this up, go and look it up on YouTube. Basically, like transformer boxes, or just look for electrical explosions, electrical box explosion. You'll see that it's quite violent and people have lost their lives because of this stuff. But resonant frequencies are the linchpin, says Bjorn Vogensmith, the principal investigator on the project and 2025 Presidential Early Career Award for Scientists and Engineers recipient. All objects have a resonant frequency, which occurs when input vibrations are maximally amplified in an object. When a sound wave shatters a wine glass, that is the resonant frequency at work. Usually, you find the resonant frequency and then turn up the amplitude, and eventually the mirror or the glass or whatever will break. In the history of civil engineering, perhaps the best known example is the collapse of the Tacoma Narrows Bridge in 1940. What happened there was the design of the bridge and the materials of its construction allowed it to flex. And as the wind pulsed across it, it flexed and flexed and flexed until it just fell apart. It was nicknamed Galloping Gertie because it actually flexed enough that it stayed in place for a while, but its strength basically broke down entirely. So in an earthquake, seismic waves cause the up and down or back and forth or both motions on the ground, and is transferred into the large transformers. Because of their flexibility and density, big power transformer tanks made of steel and filled with insulating oil can resonate dynamically. You actually see these transformers up on poles. Those can sometimes fail and they explode. The oil is there to act as insulation and cooling. So Vogensmith and his colleagues, Shandu Bolasetti of INL and John Bender of WEGAI, a Boise-based engineering firm, are seeking to tackle the problem by inventing a decoupling device that shifts the resonant frequency of the bushing away from that of the transformer. The decoupler they are designing can be easily installed at the base of the bushing and retrofitted to older transformer models for a low cost. So, at the culmination of their project, Vaughan Smith and his colleagues hope to test the resonance frequency decoupler in a big way. They managed to secure a 500,000-pound transformer, which they hope to take to the earthquake simulator at the University of California in San Diego in 2026. And they want to test what this thing looks like. I don't have a picture of this thing other than this drawing, but basically they want to decouple the transformer from its resonant, the impact of resonant frequencies on it. But the resonance comes from this entire apparatus, a 500,000-pound object. Well, good luck. Good luck to y'all. Okay, let's keep going. The next article is over in the Marble channel. Virtual time freezing techniques let scientists see inside spinning engines and tools. I'm not sure why this is. Anyway, this is by a company or an organization called Optica. They published it over at phys.org. And capturing clear images of fast-moving objects is challenging because they tend to blur or look grainy, said research team member Zibeng Zhang from Jinan University in China. Although high-speed cameras can help, they're expensive and can't be used for long periods. Our method overcomes this challenge by virtually freezing time by exploiting the repetitiveness of the object's motion. So it's kind of like flickering, like a strobe, and catching it and then stacking them together. But let's see if that's how it's actually doing it. In the journal Optics Letters, the researchers describe their new imaging system, which is based on a single pixel detector. They show that it can capture images of an object spinning at around 14,700 miles or RPM, rounds per minute. They have a video here, but I won't play the video. So the system can detect wear or cracks that can develop in high-speed metal cutting and grinding tools over time without stopping the machine, improving safety and extending the equipment's lifespan. In the future, the technology can be integrated into smart manufacturing systems via aircraft maintenance platforms, or even home appliances. They say home appliances like cars. One second. All right, sorry about that. Blenders, fans, air conditioners, hard drives, making these devices smarter and safer. Yeah, I think imaging fast spinning objects is not an easy task for conventional imaging techniques because rotation leads to severe motion blur. So let's see how they do it. The imaging approach projects pattern light onto a scene and captures the resulting intensity variations with a single pixel detector, allowing a computer to reconstruct a detailed image without needing a traditional camera sensor. Single pixel detectors are photodiodes with only one pixel available. Compared to a traditional camera sensors, single pixel detectors have higher sensitivity, a wider range, dynamic range, and faster response, making them suitable for imaging fast spinning objects. But they must only have a I'm so sorry. Sorry about that. So yeah, the imaging system captures clear images of rotating objects by aligning with the repetitive motion. This is much like painting a sunrise over several days, where each time the sun rises, the artist paints a small part of the scene. Even though the sun moves continuously, it's possible to capture the whole picture by setting an alarm to sync with the sun's daily return. It's like multiple exposures, and then they stack them. I think that's what they're doing. It's just that they're taking a picture and letting it rotate, take a picture, letting it rotate, take a picture. But because they can do it really fast, 22,000 hertz, to illuminate the rotating object with a series of patterns, the single pixel detector acquires a measurement for each pattern projection, and then basically it just stacks it together. It looks like, yeah. So to demonstrate the system, the researchers showed that it could reconstruct real-time, high-quality still images of a model jet engine, 11 centimeters in diameter, rotating at about 2,170 RPM, and a cooling fan rotating at approximately 14,700 rounds per minute. It's pretty cool. Yeah, it doesn't require any prior knowledge of the object. Can also be used to image objects with unstable rotation speed, because it's looking for something to kind of lock it down, not necessarily knowing the speed, because it captures the whole scene on one pixel. All right, let's keep going. So the next article is over in Technology Today. This tiny chip sees like an eye, thinks like a brain, and remembers instantly. Scientists have built a device that sees and thinks like the brain, opening doors to lightning-fast robotics and safer autonomous vehicles. Engineers at RMIT University have created a tiny brain-like device that can detect hand movements, store visual memories, and process information, all without relying on an external computer. Neuromorphic device is what it's being referred to as. RMIT University put the article together. It's over at scitechdaily.com. Unlike traditional digital systems that consume large amounts of energy, neuromorphic vision technology uses analog style processing similar to how our brains function. This approach has made it easy to handle complex visual tasks with far greater energy efficiency. Where do they publish this? They say that it's a proof of concept device that mimics the eye's ability to capture light and brain's ability to process that visual information, enabling it to sense a change in the environment instantly and make memories without need for use of huge amounts of data and energy. The research was published in Advanced Materials Technologies, and they say that current digital systems, by contrast, are very power hungry and unable to keep up as data volume and complexity increases, which limits their ability to make true real-time decisions. Yeah, they're pretty much lagged. They might be able to analyze everything, but by the time they've received the data, analyzed it, and processed it to the point where they can make a confirmation of something, and then either did the action, it's pretty lagged. So the team's innovative idea could one day improve response times of automated vehicles and advanced robotic systems to visual information, which could be crucial, particularly in dangerous and unpredictable environments. All right, let's keep going. The next article is Beyond the Double Helix, Strange New DNA Structures Discovered in Ape Genomes. Researchers utilized recently published telomere-to-telomere genomes of humans, chimpanzees, bonobos, gorillas, and 2 orangutans to predict where DNA sequence might form alternative structures beyond the traditional double helix. Certain DNA sequences can adopt structures that differ from the familiar double helix. The article is by Penn State, published over at scitechdaily.com, and they say here, now a research team led by biologists at Penn State have made significant progress by systematically predicting the locations of non-B DNA structures across the genomes of great apes. This marks a first crucial step toward understanding the roles these structures play in biological function and evolution. These alternative conformations, known as non-B DNA, has already been associated with genetic disease and cancer, and the breakthrough has been made possible by recently completed telomere-to-telomere, or T2T, genome assemblies, which provide complete gap-free sequences for humans and other great apes. We are a great ape. I'm going to move on. The next article is, and our final one for today's Technology Today, is over at Technology Today. One and done cure, new gel wipes out ear infections in 24 hours. Scientists may have just found a game changer for kids plagued by ear infections. A single squirt of a special gel cured the infection of animals within just 24 hours. No pills, no repeated doses, and the gel slips through the eardrum to deliver medicine right where it's needed, and it worked perfectly in every case during the tests. American Chemical Society put the article together. It's over at scitechdaily.com. Treating the infection directly at its source could prevent side effects, but there's a major obstacle. The infection sits behind the eardrum, which blocks most medications. To get around this, researchers created a tiny drug carrying bubble called a liposome to help the medicine slip through. Surprisingly, the team found that negatively charged liposomes, not the typically favored positive ones, were the most effective. They discovered that immune cells reacting to the infection helped pull in these negatively charged liposomes, allowing the antibiotic to reach the infection site more efficiently. And there you go. They found that in all the ear-infected chinchillas receiving gel containing ciprofloxacin, encapsulated in negatively charged liposomes, were infection-free within 24 hours. And furthermore, the animals showed no eardrum inflammation or recurrence of infection during the 7 days of treatment. In comparison, after 7 days, only a portion of the animals receiving gel formulations with either free antibiotic, 25%, or antibiotic encapsulated in positively charged liposomes, 50%, were cleared of infection, and the eardrum inflammation was similar to that of untreated animals. So there you go. What a deal. But that's it, folks. We are done with Technology Today for May 18th. So I hope you stick around. We always have articles and news. Monday through Friday is non sequitur news. It's an hour-long show, sometimes longer, sometimes a little bit shorter, but usually an hour. And then on Saturday, there is Reality Hacker, Wanted, and the Continuity Report. And then on Sunday is Reality Hacker, not Reality Hacker. What am I talking about? On Sunday is Warcrafters, Technology Today, this show. And after this show is Four Wheel Tech. So we'll see you soon. Before I do that, I'll bring you back to Technology Today. Just as a reminder, that's where we are. See you all soon. Bye-bye.